Welcome. In this session, we'll learn something more about uh, this convolution sum formula. We know if the input to an LTI system is x of n, whose impulse response is h of n, then the output y of n, then the output y of n can be written as x of n convolute of h of n, and this we can write as k running from minus infinity to infinity, x of n minus k, h of k. And this you can also write as k going from minus infinity to infinity, x of k, h of n minus k. Let me write this part. So this is h of n minus k. This is h of n minus k. So this property is referred as commutative property. So you can say x of n convolute with h of n is same as h of n convolute with x of n. And this property is referred as commutative property of this convolution sum. So this is referred as commutative property. So this is referred as commutative property. So whether you shift and this invert this x of n or h of n with some material in convolution. So you can call this shift and invert any sequence in this convolution file. All right. Now the second property that we shall learn is actually called the distributive property, but we learn it from the system point of view. If the two systems are connected in cascade, so if two systems are connected in cascade, so if two systems connected in cascade, system is connected in cascade. So what is the response of that system? How can we write the response of that system? So if we say these are our two systems, this is the meaning of connection in cascade. If the impulse response of this is h1n and the impulse response of this is h2n, then how you can write the this OLR impulse response of the system. Let's say x of n is the input to the first system, this is the output of the system. Then how can we write the output of this system, this whole system, which is the cascade of this system and this system. Now let me call this output, intermediate output, as y1n. Now from LTI system theory, what will be y1n? Y1n will be simply x of n convolution with h1. So this will be the convolution between these two. Now similarly, y of n is convolution of y of n with h2n. You can check it. Now the input to the second system is y1n. Now substituting the value of y1n, which is x of n, x of n, h2n. So the whole response of the response of this overall system is x of n convolution of h1n, h2n. So convolution of these three sequences xn, h1n, and h2n. So this will give us the output. So in other words, you can say you can replace this cascade system by another system whose impulse response is h of n, where h of n is simply the convolution of these two systems. So h of n is simply the convolution of h1n and h2. So the overall impulse response of two systems connected in cascade is simply the convolution of the two impulse response. In short, that's the meaning. You can say the statement two ways. You can replace the whole cascade system by another system whose impulse response is h of n. This is our y of n, and where h of n is the convolution between the two impulse response which are connected in cascade. So you can say the statement two ways. You can say we can replace this whole cascade system by another system whose impulse response is this, or you can say the overall impulse response you can determine by first convolving the x of n with h1n, meaning the impulse response of first system, then taking this output and convolving it with this will give you the overall response. Or you can do it like this. You can first take the convolution between two impulse responses, then get the output by convolving the overall impulse response. So this is how you calculate the output of a cascade system. So if two systems are connected in cascade, the overall impulse response is simply the convolution between two impulse responses. Same way, if the two systems are connected in parallel, so if the two systems are connected in parallel now parallel means simply this. Will be the output of this system. What will be the output of this system? Let's suppose the output of first system is y1n and the output of second system is y2n. So y1n you can write simply as x of n convolution with h1 of n. You can check it from here. Input to the system is same, so output of this first system will be h1n convolved with x of n. Similarly, the output of second system will be x of n convolution with h2. Now the overall response you can see is the sum of the two individual responses y1n plus y2n. So substituting the value of this y1n and y2n, you can get the overall response. Now that this is h2n. Now taking x of n common, you can say this is h1n plus h2. So taking this convolution and x1n common, you can say this is equal to this, and you can say this is simply the convolution between x of n and some h of n, where h of n is the sum of the impulse response of two individual systems. So the total impulse response when the systems are connected in parallel is simply the sum of these individual impulse responses. So you can say you can replace this system by another system, this parallel system by another system. This h of n is the overall impulse response, where h of n is h1n plus h2n and y of n is the. So when two systems are connected in cascade, the overall impulse response is simply sum of the individual impulse response. Let us solve an example to illustrate these concepts. Let's suppose we have a system that looks something like this. Let us suppose we have a system. We have a very complicated system that looks like this. So this is our system. And this is this is our n, this is our x of n. X of n is input, y of n is output. So n is where these impulse response are given to us, where h1n is equal to u of n. h2n is u of n plus 2 minus u of n. And h3n is delta n minus 2, and h4n is L4 is for n u of n. So this is our system. Our aim is to determine the overall impulse response of this system. So we are given systems that are sometimes connected in parallel, sometimes in cascade, and again parallel. Our job is to calculate the overall impulse response. Now we said we can replace this system, this two systems are connected in parallel. We can replace that system simply by a single system which is simply the sum of the individual impulse responses. So what we'll do, we can replace this system by another system. Let's call it h dash n, and this is our h3n. Rest will remain same. This is our h4n, and this is the sum of the two. This is our x of n, and this is our n of n. Now what's h dash n? H dash n is simply h1n plus h2n, because these two systems are connected in cascade. So what's h1n? H1n is u of n. What's h2n? U of n plus 2 minus u of n minus u of, and now you can see u of n cancels with u of n, it will be u of n plus 2, simple. Now h dash n, you can see, is now in cascade with this system. So this system and this system now are in cascade. So we can replace this system by a single system. Let's call it h double dash n. Then rest will remain same. So this is 4n, this is x of n, and this is y. Sorry, this is y n. So h double dash n will be simply h dash n convolution with convolution with h3 of n. What is h dash of n? H dash of n, you can solve. We just calculated u of n plus convolution with this convolution with what is h3n? Delta n minus 2. So this will be delta n minus 2. So the convolution of any sequence with delta is the same delta. Sorry, is the same sequence. Now this time we have shifted delta. Just replace the shift by n, means replace the n in the original sequence. What you have to do, see, if x of n is convolved with any delta n minus k, just replace n by this shifted version, means replace n by n minus k. Alright, so if I put u of n instead of n, I have to put n minus 2, then there is plus 2 also. So you can say this is simply u of n. So h double dash n is u of n. Now again, these two systems are in cascade. So you can say you can replace this system by h of dash h3 dash n. Now the output is this. So h triple dash n is simply these are not in cascade, these are in parallel. So we can say the overall impulse response is simply the sum of these two individual impulse responses. So this will be sum of these impulse responses. Sum this one. What is H double dash n? H double dash n is U of n. What is H4 of n? What's H4 of n? Where is H4? H4 of n is alpha raised for n U of n. Alpha raised for n U of n. And you can see if we take one common, this will be, sorry, U of n common, this will be U of n. So this is how we write the, is there plus, okay, this is plus. Alright, so this is the overall impulse response of this system. So this is the overall impulse response of system. Now see H triple dash n, which is the overall impulse response. We wrote it in terms of H double dash n plus H4 of n. And what was H double dash n? H double dash n was simply H dash n convolution with H3 of n plus H4 of n. And what was H1 of n, H dash of n, it was H1 of n plus H2 of n. And this is convoluted with H3 of n plus H4 of n. So this is how we derived the overall impulse response of this system. So these are some properties of this convolution. These are in terms of the system notation. So please solve the further examples from your book. These are sometimes this property, this cascade property is also referred as this distributive property of this convolution. This is also referred as distributive property of this convolution, and this parallel property is sometimes referred, if you say it in terms of numbers, this will be simply an associative property of convolution. But we did it in terms of system notations. We followed these in terms of system notations. I hope you understood the concept. Okay, let me stop here.